Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique square pyramid which is having edge of the base equal to 30 millimeter and the axis height it is equal to 50 millimeter. Now this square pyramid, it is located into the inverted orientation in such a way that the apex of this square pyramid is resting onto the horizontal plane and one of its slant edges, it is vertical. Vertical means that it is perpendicular to the horizontal plane. So let us first of all evaluate the orientation of the square pyramid with respect to the horizontal plane. If we locate the square pyramid into this orientation, then what will happen? These two slant edges OA and OB, they will be overlapping, and these two slant edges OC and OD, they will be overlapping over here, because this will be A, B, C and D. And what will happen if we make one slant edge perpendicular to the horizontal plane, or if we make it vertical? So rather than one slant edge, so two of the slant edges, they will be becoming vertical or perpendicular to the horizontal plane. So this orientation of the square pyramid is incorrect. Whereas if we locate the square pyramid onto the horizontal plane in this orientation, then this will be OA slant edge, this will be OB, this will be OC and this will be OD slant edge. So we can make one slant edge perpendicular to the horizontal plane, or we can make one slant edge vertical over here. So we can make one slant edge perpendicular to the horizontal plane over here. So the two slant edges OB and OD, they will be overlapping. Then there will be four slant edge OC which will not be perpendicular to the horizontal plane. So this way we can make one slant edge perpendicular to the horizontal plane, or we can make it vertical over here. So this orientation of the square pyramid, in which the two edges of the base, they will be oriented at an angle of 45 degree with respect to the vertical plane. Now in the second orientation, we have been provided with the information that the triangular face which is containing this slant edge which is perpendicular to the horizontal plane, this triangular face, this becomes perpendicular to the vertical plane. Now you can see over here, in the first instance we had made slant edge O dash A dash, that is OA slant edge, we had made perpendicular to the horizontal plane, or we had made it vertical. Now there are two faces, that is two triangular faces, they are available. The first face is OAD. This is first triangular face which is containing this perpendicular or the vertical slant edge over there. Or there is another triangular face which can be OA and B. So any one of these two triangular faces which is going to contain this vertical slant edge, so this triangular face we have to assume either one of these two, OAD or OAB. So this triangular face we have to assume that it is, the solid is rotated in such a way that the triangular face containing this vertical slant edge, it becomes perpendicular to the vertical plane. So this way, this inverted square pyramid, it is inclined with respect to horizontal plane as well. It is inclined with respect to the vertical plane as well. So we have got an oblique square pyramid which is inverted in nature, and it is having its apex contained by the horizontal plane over there. And we are required to draw the orthographic projections, that is the front view and the top view projections of this oblique square pyramid. So let us proceed with the construction of the orthographic projections of this inverted square pyramid to begin with. So as we have discussed that the orientation of the square pyramid will be such that both of the edges of the square pyramid will be inclined at an angle of 45 degree with respect to the vertical plane over there. So we have drawn a projection line at an angle of 45. We know that the edge of the square pyramid happens to be 30 millimeter. So with respect to this orientation of 45 degree, now we have drawn a square having edge equal to 30 millimeter over here. So this point we have marked as point A. This will be point B. This is point C and this is point D. So all the 4 points corresponding to the side or the edge of the square pyramid, they have been drawn, as we are going to look at the square pyramid from the top view projection over here. So all the 4 edges AB, BC, CD and DA, they will be visible to the observer, as the observer is going to look at this inverted square pyramid from the top. Now let us locate the apex or the axis point over here. In order to locate the apex point, we can join the diagonals AC and BD over here. The moment we join these diagonals, we will be able to locate the apex point or the center point over here. And the center point will be labeled as O and O1 over here. So we have drawn a square pyramid having edge is equal to 30, located the axis point. So we know that the height of this axis of the square pyramid happens to be 50 millimeter. So the axis height we are going to take as 50 millimeter. Now let us join all the 4 slant edges over here. We can see OA, OB, OC and OD. So all these 4 slant edges, they will not be visible to the observer from the top. So that is why they have been represented as OA, it is a hidden line. OB slant edge, it is also a hidden line. OC slant edge, it is also a hidden line. And OD slant edge, it also happens to be a hidden line over here in the top view construction over here. So now let us draw the front view projection. So in the front view projection, we know that the axis height of the square pyramid happens to be 50 millimeter. Now here we are going to get the top face of this particular square pyramid. And what will be its dimension? So we draw a vertical projector from A and extend it up to a height of 50 millimeter. Similarly, we draw another vertical projector from C, extend it up to a height of 50 millimeter. And once we join this edge over here, so we will be able to get the projection of the top face of this particular square pyramid over here. Now having obtained these projections, now you can see we can label these points. So point A will be projected as point A dash on the top face. Similarly, point C will be projected as point C dash on the top face. Points B and D, they will be projected as B dash and D dash on the top face over here. So apex point is resting on to the horizontal plane. So point O dash will be the apex point which is resting on to the ground. Similarly, this point will be O1 dash over here. So this way we have been able to obtain the front view orthographic projections and the top view orthographic projections of an inverted square pyramid in which the top face edge happens to be inclined with respect to vertical plane at an angle of 45 degree and the apex of the square pyramid happens to rest onto the horizontal plane. Now we have been provided with the information that one of its slant edges, it can be the edge OA or it can be the edge OC. So we have chosen the edge OA over here. So now we are going to rotate or incline this inverted square pyramid in such a way. We are going to incline it this way. Please check. We have not been provided with the angle of inclination over here. Rather, the information is this, that one of its slant edges, which is O dash, A dash in this particular case in the front view projection. So this slant edge O dash, A dash in the front view projection, it becomes perpendicular to the horizontal plane or it becomes vertical. So this triangular inverted projection that we have obtained corresponding to this inverted square pyramid with apex resting onto the ground. So this is tilted in such a way that this edge OA should become perpendicular to the horizontal plane. Now you can see we have marked a perpendicular projector line over here, or a construction line, and onto this perpendicular projector line our dimension of the slant edge O dash A dash will be resting over here. So I need to mark O1 dash point over here and A1 dash point over here. So O1 dash, A1 dash points, they have been marked over here. And once I mark these 2 points, so this is a simple triangle. I know the dimension A dash C dash, I know the dimension O dash C dash. So now once I measure this distance O1 dash, A1 dash, now from this point I will be marking an arc equal to the distance A dash C dash over here. So from A1 dash I will be marking an arc equal to the distance A1 dash C1 dash, and then from O1 dash again I will be marking another arc which will be having the distance or the radius is equal to O dash C dash over here. So from here I'll be cutting the distance or marking the distance over here equal to O dash C dash over here. So once I mark this distance, I have been able to successfully transfer using rectilinear distances this triangular front view projection from the present orientation into a new orientation in which one of the slant edges of this square pyramid happen to be perpendicular to the horizontal plane. And I also know this distance. So this distance, once I mark it over here, so the axis point of the base also I will be able to locate. So this way, all the points of this triangle projection in the elevation, they have been appropriately marked. So now I can transfer this figure over here. I'll find that the new projections, they include O1 dash, A1 dash, which is perpendicular to the horizontal plane or which is vertical. So this is the slant edge that we were talking about. So OA edge we have oriented in such a way that this edge has become perpendicular to the horizontal plane or it has become vertical, and correspondingly B1 dash, D1 dash, C1 dash and O11 dash points, they have also been obtained into the elevation projection view corresponding to this inclined inverted square pyramid. So having obtained the front view projections of this inclined inverted square pyramid, now how many points they are available? 1, 2, 3, 4, 5, 6. So these 6 points in the plan projection view we need to obtain over here. How we are going to obtain the plan projection corresponding to this particular inverted inclined square pyramid from these 6 points of the elevation? Now we are going to draw the vertical projector lines as the observer is going to look at this inverted pyramid from the top. So now we can see we have drawn the vertical projector lines through these 6 elevation projection points, and now we are going to draw the horizontal projection lines through the corresponding points from the plan projection view which we had obtained earlier, and wherever the intersection of the corresponding points will be available, we will be able to obtain the plan projection of the points in the top view projection onto the horizontal plane. So here we can see, here we have drawn the horizontal projection through the point D. Here we had drawn the vertical projector through the point D1 dash. So the intersection of these 2 points will provide us with the location of the point D1 over here. So here we have got 2 points A and C as well as O and O1. So 4 points are located alongside this horizontal line. That is, onto this horizontal projection line, 4 plan projections they will be made available over here. So let us evaluate all of these 4 points. Now we can see that here we have got the vertical projector line drawn through the point A1 dash. Here we have got horizontal projector line drawn through the point A1. So the intersection of these two projector lines will provide us with the location of the point A1 over here. Similarly, here we have got vertical projector line drawn through the point C1 dash of the elevation projection view. Here we have got the horizontal projector line drawn through the point C of the previous plan projection view. So the intersection of these two lines, they will provide us with the location of the point C1 over here. Similarly, here we have got the point O1 dash in the elevation projection view. Once we draw the vertical projector line through O1 dash, wherever it intersects with the horizontal projector line drawn through the point O, we obtain the point O1 over here. Similarly, here we have got vertical projector line drawn through the point O11 dash. Wherever it intersects with the horizontal projector line drawn through the point O1, we obtain the point O11 over here. So this way 4 points we have been able to locate onto this horizontal construction line. And finally the 6th point of the plan projection view we are going to obtain over here. So this is the point B. So once we draw a horizontal locus line or a projection line through the point B, wherever it intersects with the vertical projector line drawn through the point B1 dash of the elevation projection view, here we are going to obtain the point B1 over here. So please check all the 4 points of the top face A1, B1, C1, D1 have been obtained, and the access points O1 and O11 also have been obtained. So which are the edges we are going to join? We have to join A1, B1, B1, C1, C1, D1 and D1, A1. We are also required to join O1, A1, which is a vertical point. We are also required to join O1, B1, O1, C1 and O1, D1. So 4 slant edges corresponding to the apex we have to join, and 4 edges corresponding to the top face we have to join. But which one of these edges will be drawn dark and which one of these edges they have to be drawn using the hidden line, that needs to be evaluated. So when the observer is going to look at this inverted square pyramid from the top, so we will see that O1 dash is the point which is farthest away from the observer. So anything joining O1 from the top view should be drawn as a hidden line unless it falls into the boundary of the solid. Similarly, O1 dash, C1 dash, it is the slant edge which is lying on the lower side, on the bottom side of the solid. So this will not be visible to the observer from the top. So one edge we have already identified, O1 dash, C1 dash, because it is lying at the bottom side. So this will not be visible. Otherwise we will check whichever edges originating from O1 dash, they are not falling in the boundary, they will be drawn as a hidden line. And another thing, the top face A1, B1, C1, D1, it is visible to the observer because it is lying at the top. So A1, B1, C1, D1 has to be drawn using object line. You can see this is the top face which is visible to the observer. Now first slant edge, because it is perpendicular to the horizontal plane, it appears as a point view in the top view projection. So there is no need to join O1 with A1. Now let us join O1 with B1, but here O1, B1 falls into the boundary. So this has to be drawn as a dark line or the object line. O1, D1 again falls onto the boundary. So it is again to be drawn dark, it is not to be drawn dotted. Now the next slant edge is OC, that is O1, C1, and we have already discussed O1 dash, C1 dash, it is lying on the bottom side of the solid. So this will not be visible to the observer. So O1, C1 will be visible as a hidden line. So we have drawn it using a dotted line over here. So this way we have been able to complete the top view projections of this inverted inclined square pyramid in which the slant edge O dash A1 dash happens to be perpendicular to the horizontal plane. Now in the second iteration we have been provided with another information that this is the slant edge which is in focus now. Which is the slant edge? OA, that is O1 dash A1 dash, or it is O1 A1. there are two triangular surfaces which are containing this perpendicular or the vertical slant edge. So the first one is OAD triangular face and the another triangular face is OAB. So now we are going to focus upon the triangular face which happens to be OAD. This is O, this is A, and this is D. This is one triangular face that we are going to talk about. So please check into this plan projection view. Now we are going to talk about this surface. This is a triangular surface which appears as an edge view into the top view projections of this inclined inverted square pyramid. O1, A1 and D1 over here. So this is O1, A1 and D1. So this is the surface you can see which we are talking about. So this is a triangular face which is containing this vertical edge over here, which is containing this vertical slant edge OA. So now into this new view, we have to rotate or translate this plan projection view in such a way that the surface O1, A1 and D1, it should become perpendicular to VP. Now this plan projection view will be reoriented or rotated in such a way that this surface, this is a triangular surface. So this we have to visualize using this particular representation OAD. So this is O1, A1, D1. So this triangular face should be located perpendicular to the vertical plane over here. So now we are going to again rotate this top view projections over here or the plan projection view such that this surface O1, A1, D1 will be oriented alongside this perpendicular projection line that we have drawn over here. So again, using rectilinear distances, we are going to transfer this plan projection view over here in such a way that O2, A2, D2 will become perpendicular to the vertical plane. And accordingly, we are going to locate the points B2 and C2 in the rectilinear fashion over here. So how this will be done? So please check O2, A2 and D2. So these 2 points we have located over here. O2 and A2, they have overlapped with each other as a one point, whereas D2, it is a separate point which we have marked over here. So this distance we know. Now from D2 we will measure this distance O11. So this distance we will measure from D1 and this distance we will measure from A1 and O1. So these are rectilinear distances which we have measured. So once we measure this distance and this distance, so now from D2 we'll mark an arc over here equal to this distance or equal to this distance. Similarly, from A2 we will measure this distance of O11 and we'll mark another arc. So once we mark these two arcs, so this dimension and this dimension will be drawn over here. Now once you double this dimension and again you double this dimension, so points C2 and B2, they will automatically be located. So this way you can rotate or transform the plan projection view obtained earlier in such a way that this triangular surface O1, A1, D1 containing this vertical edge O1, A1, it becomes perpendicular to the vertical plane. So having obtained this transformed projection of the plan projection view, now we have been able to obtain the plan projection of the oblique inverted square pyramid over here. So the top view projections of this inverted square pyramid have been appropriately obtained onto the horizontal plane. Now again 6 points they were available. Now finally we are required to obtain these 6 points corresponding to the oblique inverted square pyramid onto the elevation projection view. So how that can be done? Once the observer is going to look at the solid from this direction, now 6 points they are available. So through these 6 points, the vertical projector lines we have drawn into the elevation projection view, and wherever these vertical projection lines, they will be intersecting with the horizontal projector lines drawn through the elevation projection points available from the previous elevation projection view. So the intersection points, they will be providing us the location of the elevation projection points of the oblique square pyramid. Now here we can see we have drawn a horizontal projector line emerging from A1 dash. So wherever it intersects with the vertical projector line emerging from the point A2, we are able to obtain A2 dash as the intersection points over here. Similarly, from B1 and D1, again we have drawn a horizontal projector line. So 3 points they are available over here, O11 dash, B1 dash and D1 dash. So onto this horizontal line, 3 elevation projection points we are going to evaluate. So here we can see the first point is B2 dash. So we can check there is the vertical projector line emerging from B2 over here. So wherever this vertical projector line intersects with the horizontal projector line emerging from B1 dash, so this intersection point provides us with the location of the point B2 dash over here. Similarly, this is point D2. We have drawn a vertical projector line through D2. Wherever this vertical projector line intersects with the horizontal projector line emerging from the point D1 dash, it provides us with the location of the point D2 dash in the front view projections over here. And finally, we have got this point onto this line O21. So from O21, we have drawn a vertical projector line. Wherever it intersects with the horizontal projector line drawn through O11, we are able to locate the axis point corresponding to the top face as O21 dash over here. Next, we have got the point C1 dash. From C1 dash, we have drawn a horizontal projector. Wherever this horizontal projector line, it intersects with the vertical projector emerging from the point C2 of the top view. So this intersection point of these two projector lines will provide us with the location of the point C2 dash in the elevation view. And finally, here we have the apex point which is resting onto the ground. So this apex O1 dash point, once we draw a horizontal projector line through this point, now wherever it intersects with the vertical projector line drawn through the point O2, so this point will provide us with the location of the point O2 dash over here. Now 6 points we have already obtained. Now which edges we need to join? We need to join this face A, B, C, D, that is A2 dash, B2 dash, C2 dash, D2 dash and A2 dash. And next 4 slant edges we need to join: O2 dash, A2 dash, O2 dash, B2 dash, O2 dash, C2 dash and O2 dash, D2 dash. But which one of these edges they will be drawn using object line or dark line? Which ones will be drawn using the hidden line or the dotted line? Now please check. As the observer is going to look at the solid from this side, so D2 is the farthest point. So anything joining D2 should be drawn as a dotted line or a hidden line unless it is appearing in the boundary. So unless any of the edges it is appearing in the boundary, it will be drawn as a hidden line or a dotted line. So please check, we have joined A2 dash, B2 dash, B2 dash, C2 dash, again dark, D2 dash, C2 dash, it has been drawn dotted. Why? Because it is not appearing in the boundary. So it has been drawn as a hidden line or a dotted line. But this edge, A2 dash, D2 dash, it is appearing in the boundary. So it will be drawn as a darker one. Similarly, O2 dash, D2 dash, again it is appearing in the boundary. So this will be drawn as darker line. And O2 dash, A2 dash will be drawn dark. O2 dash, C2 dash will be drawn dark. And O2 dash, B2 dash will also be drawn dark. Now here we have the front view projections of the oblique inverted square pyramid, in which one of the slant edges, it happens to be vertical or perpendicular to the horizontal plane, and a triangular face OAD which is containing this vertical edge, it is also rotated with respect to vertical plane in such a way that this triangular face, it becomes perpendicular to the vertical plane. So this way, the top view projections as well as the front view projections of this oblique solid, which happens to be inclined with respect to the horizontal plane and it happens to be inclined with respect to the vertical plane, has been obtained. So this way, here we have an inverted square pyramid which is oblique solid, and we have been able to obtain the orthographic front view and top view projections of this oblique solid using the principles of projections of the solid over here. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the oblique solid when the solid happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So we are going to continue with further discussion regarding few more illustrative cases of projections of the oblique solids in the coming lecture discussions over here. So thank you very much. Thanks a lot.